So here is a problem from the 2018 to 2019 USAMTS. A cyclic quadrilateral ABCD has AC perpendicular to BD, AB plus CD equals 12, and BC plus AD equals 13. Find the greatest possible area of ABCD. So first, we can draw in the diagonals, and then we let A be the length from A to the intersection point, and then similarly we have B, C, and D. So first, notice that if we try to find the area of ABCD, we can split it into these four triangles. And that would mean that the area is AB plus BC plus CD plus AD all over 2. And we can factor that into A plus C times B plus D over 2, which is AC times BD. So next, we can use Ptolemy's theorem, which says that in a cyclic quadrilateral, the product of the diagonals is the sum of the products of the opposite sides. So in this case, we have AC times BD is equal to AB times CD plus AD times BC. So now we want to find the greatest possible area, which is AB times CD plus AD times BC over 2. So now we use the fact that AB plus CD is equal to 12. So notice that if we expand out the square, then we have AB squared plus CD squared plus 2AB times CD is equal to 144. And similarly, we have an equation for BC and AD. And now, by the Pythagorean theorem, we have each of these four relations. So A squared plus B squared is AB squared, and so on. So if we plug this into the previous two equations that we have, then we have B squared plus C squared plus A squared plus D squared plus 2 times BC times AD is equal to 169, and A squared plus B squared plus C squared plus D squared plus 2AB times CD is equal to 144. So adding these two equations, we would get that 2 times A squared plus B squared plus C squared plus D squared plus 2 times AB times CD plus AD times BC is equal to 313. And notice that the second term is just 4 times the area of the quadrilateral that we want to find. So in order to maximize the area, we want to minimize the other term, which is the sum of the 4 squares. So to minimize the sum of those 4 squares, which can also be written as AB squared plus CD squared or BC squared plus AD squared, we can use the AMGM inequality. So essentially, the AMGM inequality states that the arithmetic mean of a set of numbers is greater than the arithmetic mean of a set of positive reals is greater than or equal to their geometric mean. So in this case, if we apply it to AB and CD, then we have that AB squared plus CD squared is greater than or equal to 2AB times CD. And then if we apply it to BC squared and AD squared, then we have BC squared plus AD squared is greater than or equal to 2 times BC times AD. And notice that if we combine this with the equations that we have before, then we have that AB squared plus CD squared is greater than or equal to half of 144, which is 72, and then BC squared plus AD squared is greater than or equal to half of 169, and that is greater than the 72 that we found previously. So that means that A squared plus B squared plus C squared plus D squared is at least 169 over 2. So so now therefore we have that the area of the quadrilateral, which is this expression, is equal to 1/4 of 313 minus 2 times A squared plus B squared plus C squared plus D squared. And if we plug that into the equation, then we have we get 36 as the final result. So that means that the greatest possible area of ABCD is 36.